In this video, we will learn about algorithm, flowcharts, and pseudocodes. Basically, algorithm is a step-by-step plan that we follow to solve problems that in our daily life and or to complete processes. So that's usually could be as simple as any examples that we face, like let's say if your computer does not start, what could be the issue, and mainly what steps you will take to try to address. We try to do the steps as simple as we can. So usually we start big and make them into smaller steps so that somebody else could follow the order for the steps. And we learned about a process called Dr. Pi, so that's a good way of following that. And by following these algorithms, we usually make the problem easier to follow and for the program to easier to understand and to be implemented. So let's first look at the Dr. Pi, which are the 5 steps. So these steps are called Dr. Pi stands for DRPIE. So that's mainly these are the 5 steps we should follow, or logically we follow when we try to solve problems. The first one is define. Basically, you just need to define and exactly understand what's the problem, because it's a key step to solve the problem is to know, to be able to define the problem and know the assumptions. And the second step is represent, which is can try to display the problem in an easy way for you to visualize it, and for people you working with you to make sure everybody understand the problem in the same way. And then after you define the problem, you present the problem in visually in a form that's everybody understand the problem. Then you start planning how to address the problem and or to do the process. And in this case, we will be learning about two different methods of doing that. We call that the flow chart, which is a good way to present the steps that we are going to take in addressing the problem. And we have another way in programming, we call that the pseudocode, which is just a step-by-step procedure for how you are going to address the problem. And then you keep revising that until you get to the point that you are comfortable that the plan will work. And then the last step is you evaluate the plan and mainly the algorithm that you started, and if it is working or not, and if we need to make any adjustment in the plan. So that's mainly the evaluation. And when you address the problem, you have to follow a structured problem solving. So always start top down. We call that top down, means start from big to small. So start with big steps, then try to each big step to divide it into sub steps or sub tasks. So always start big, and then see if you can divide that big task into smaller tasks until you get smaller and smaller until you can't get any smaller. And follow that with the stepwise, so that all the steps happen in logical order. And as I mentioned, we will learn about two methods of doing the algorithm for problem solving. The first one, we call that pseudocode, which is when we write a program, but this will be informal, which is just mainly English-like coding. So just for each step, you just write it, what you intend to do for that. So that's programming light, because it's just a plain English, and merely putting the steps in a sequence of what you plan to do to solve the problem. The other method to solve the problem is to use a flowchart, which is many people prefer flowcharts over pseudocodes, which is easy for us, to visualize. Just follow certain steps. We will learn about the different shapes and for what purpose each shape is used. So that's the way, and you will be also we'll show an example that we will do both pseudocode and flowchart, and you need to learn both of them in this course. When you are addressing problems, you are encouraged to do at least one of them. Flowcharts, they will help us visualize the program or the logic behind solving the problem or completing a task, and it's the more related to the represent and the planning step of the Dr. Pi process. And you are encouraged to make a flowchart before writing any program, because it will save you a lot of time, and you can predict what could happen wrong before you try to run the program, and make it easier for you to troubleshoot the program. These are the different shapes that are used in making flowcharts. And again, some books or some programs use different shapes, but this is kind of what we will be following here. Usually you start the program with the start, and you end it with the end. And for that, we are going to use the oval shape. And most of the time you will be writing a process, just the steps, like I'll do this and that, just sequence of steps. So you do one after the other, and you just arrow from one to the other. So that will be the rectangles for the processes, which is what will happen next. And another important one we will learn about is a decision. And the difference between a process and process is just one step, which is just doing one thing. Decision has multiple options, so you could, if anything has the two options, then that's considered a decision. And usually when we write it here, it should be an if, it should be a question with a yes, no answers. Or if we are doing the pseudocode, because we can't do it this way, we just write it as an if statement. So if this happened, then go this way. If the other option happened, then go this way. So that's mainly what we will be doing for that. So just remember that the diamond shape is used for when there's a decision, which means you have multiple options. And the process, if you have only one option, that to go from one step to another step. Sometimes we will be asking the user to input results, like input a number or a name or any other variable that we want. So we use that shape, like the trapezium shape, for that. And then we may want the program to write something or to read something from the screen, and that we use the parallelogram shape for that. And then another one is like the hexagon for if there is we call that loop, or something that happen multiple times. If we just want to do something multiple times, we will learn about this called loops. So that's an important, and mainly every programming has that component. So we can use the hexagon shape for that. Okay, let's look at an logarithm example here, which is, we could just pick something simple here. So like a task or a problem. So mainly have a person fill a bottle with the stones. So it could be just like a simple process, but we need to learn how to follow that step by step a plan for doing that. So that's, you just don't need to just say, yeah, I just fill the stones in the bottle. So we have start with the assumptions. So assume that you have the bottle already exists and the stones already exist, and let's say assume that the stones are not the same size, so that just to make it more to give you more options for that, and maybe some of the stones could not fit in the from the opening of the bottle. So what will be the steps? So that's mainly you have to follow that Dr. Pi process, trying to put a plan and start big. This is the big picture here. We want to fill the stones in the bottle, but we need to give a detailed step by step process and how we are going to do that. So different people could think different, but as long as we get to the result for that. So let's look at what could be an example for a flowchart and the pseudocode to doing that process. And here's an example of using the pseudocode to address that, to filling the stones in the bottle. As you can see here, we could make it just one big step, fill the bottle with the stones, but we have to be more specific. So you can see we put that in 7 or 8 steps. So we could say start, then set the bottle upright next to the stone. If the bottle is closed, open it. Then if it is open, we just proceed to the next step. And then if the bottle is full, then go to step 7, which is to stop. Mainly we do this so that we can keep running, keep adding more stones. And then we select a stone, we try to place it in the bottle. That could be, if it is big, then we discard it. We go back to step 3. If it fits in the bottle, then we proceed. We place the stone in the bottle, then we go back to step 3. We check, is the bottle full? If it is full, we go to the stop. If not, then we proceed to step 4. We select another stone and we try to place it in the bottle. Then if that stone is too big, we discard it and we go back to step 4 to select another to step 3, I mean, to see if the bottle is full. If not, then we proceed to step 3. So you can see this is kind of the way how you are going to address the programs that we are going to do in this course, and you have to make it kind of stepwise, with putting the big picture first, then you go from top down until you simplify it and you make sure it's working and nothing is missing, and you don't stop in one place. So let's say if you don't go to step 3, so then think about it like the computer here. The computer, without putting that step, it will stay there forever. So this is why we have to account for every step there. So discard the stone, and then it will sit there without not going back or going forward. So then this is why you need the last step here, go to step 3, or in this case, if the bottle is full, if you don't put that, then it will stay there, but we need to go to step 7, then we can finish the program. And this is the same thing, the bottle and stones example with the flowchart format. So that's kind of the same steps we saw, but this is in a flowchart, and you can see start again. We could use the oval shape for the end and the start, and the diamond shape is for if there is a decision. So you can see there are 2 decisions here that has multiple options, and we use the rectangle shape for just regular step if there is no decision there. So there is no yes, no questions there. So you start, you can put any stone left, which is just mainly to check for that, and then which is just mainly we need that step. We could put it later, which works better for you, and I'll try that with another way of doing that. So then you get the stone, so that somebody could decide to put this first, and then you just check the stone. Does the stone fit? If yes, you put the stone in the bottle. If not, then you discard the stone. And again, we go back to back to the previous step to check if otherwise the computer will sit here forever. And then if the stone fits, then you place the stone in the bottle, and then you check if the bottle is full. Then you end the process. If it's not full, then you go back and check, bring another stone, and you just check if there's any other stone left. If it is left, also you need to check if it fits, and just follow the procedure here. So that can help, can show you the process there. And again, everyone could use different process as long as you are using the shapes. So you have to learn how to use especially the decision shape. So you have to use the diamond shape with yes and no. In this class, we will be using diagrams.net to make our flowcharts. And so this is kind of another way we did it here, so to show you the different processes, and mainly just to show you both the flowchart and the pseudocode together in the same sheet. And actually, we could also do the pseudocode using diagrams.net. And these are the different shapes that you could pick and draw. We'll show you that in different video, how to use the diagrams.net to make flowcharts. So this is kind of the same thing. So this is the example. So we start, and then we set the bottle. So we use that shape, that rectangle shape for the process. So we set the bottle upright next to the stone, which is you can see this are the same steps. So step 2 and this are the same. And then we have a decision: is the bottle closed? If it is closed, we open it. So then you can see for pseudocode we can't put a question, so we have to use if statement. So make sure every time if you have a question, you have to use if statement. And for that side options, you have to put them indented. So it means that you are not going straight. So whatever you have there. So in this case, the yes, is the bottle closed? If the answer is yes, then you open the bottle, and then you go to step 4, which is select the stone. So that's always, if you have a decision in a flowchart, use a diamond, and in the pseudocode you use the if statement. And for the side 1, you could use another if statement for the next one, but there is no need for that as long as it's going straight. But sometimes we call it nested. You could use another if statement, so you could also indent more. So then we go to step 4, select a stone, which is here, select a stone. And then we proceed to the next step, try to place the stone in the bottle. So try to stay, so that's step 5. This is the same thing here. And then we have another decision. So that's the question: is the stone too large? So that's mainly, we use a question for the diamond shape or for the flowchart, but we change that into an if statement for the pseudocode. So that's if the stone is too large, then discard the stone. So that's what you see here. So mainly the side, or the one that's not with the flow, we put it as indented, and then we go back to step 4, which is select a stone. So go to step 4, which is select a stone, which is what you see it here. And then if the stone is not too large, which is there is no need to put another if statement. We just go straight to the next one to place the stone in the bottle. So that's step 7. And then we have another decision, and that's again if the bottle is full, or I mean here, because I want to show the side option. If the bottle is not full, go to step 4, which is select a stone. So go to step 4 here, which is select a stone, and just keep doing that until the bottle is full, then we go to stop. So we go to stop there. So that's an example of how to show you the flowchart and the pseudocode side by side. As I said, some people prefer to visualize things, so they prefer flowchart, which is, I think, myself, I prefer flowcharts, but some people also like to write them, and sometimes you need a combination of both, because you write the steps, then you put it in a flowchart and see if anything is missing, like what we saw here. And as I said, think about it from the computer side. So if you just discard the stone and you don't put the back arrow here, then it will, the program will stop here and it will not go anywhere. So you have to account for that and do the step there. The same thing if you don't put this step here, then the computer will not understand, so it will keep adding stone and stone, so it will never go to the end. So that will be like infinite loops. It will never stop. Basically, it could just keep running here without going to a stop. So hopefully that can give you a good idea about the difference between flowcharts and pseudocode, and how are we going to use them to solve problems. I mean, to write programs and to do activities, which is something we do in our daily life, but we don't realize that this is how our minds work, and how we do decisions, and how we do processes. And let's look at another example for how to use the algorithm and the flowchart in making friendship from the Big Bang Theory. So let's start that.
I've isolated the algorithm for making friends. Sheldon, there is no algorithm for making friends. Well, hear him out. If he's really onto something, we could open a booth at Comic-Con, make a fortune. See, my initial approach to Kripke had the same deficiencies as those that played Stu the Cockatoo when he was new at the zoo. Stu the Cockatoo? Yes, he's new at the zoo. It's a terrific book. I've distilled its essence into a simple flowchart that will guide me through the process. Have you thought about putting him in a crate while you're out of the apartment? Hello, Kripke. Yeah, Sheldon Cooper here. It occurred to me that you hadn't returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yeah, perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time for a hot beverage. Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. Tell me an interest of yours. Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours. Uh-oh. He's stuck in an infinite loop. I can fix it. It's interesting, but isn't ventriloquism by definition a solo activity? Yeah. Wait, tell me another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on, Kripke. A loop counter and an escape to the least objectionable activity. Howard, that's brilliant. I'm surprised you saw that. Gee, why can't Sheldon make friends? All right, Kripke, that last interest strikes me as the least objectionable, and I would like to propose that we do that together. Tomorrow. Yes, I'll pay. Goodbye. All right. Time to learn rock climbing.
And here's how you use the diagrams.net to make your flowchart that you need for this course. So you go to diagrams.net. Then you could either click on start or start now. And then if you already have a program before you can open it, and if it's saved in your PC. In this case, we want to create a new diagram, and then you could use the flowcharts already developed for you, like they are different templates, but like in this case, we could use flowchart templates. You can see there are different templates already created for you, so you could use a template, or you could start something from scratch. So let's start blank, or again, you could either use a flowchart here, or you could use a blank, and then you create, and then you start dragging shapes, and you could write like this one, start, and then you drag other shapes, and just by clicking there, you can put the arrows and just put more shapes, and then you could drag, you could change the size, and then you could use a diagonal to make decisions, like what we said before, add other steps, and so on. So just keep doing that. Then you save it, or also before you save it, when you are need to send it as an assignment, you need to export it in something other than the format for diagrams. So you get to File, and you export as. So you either pick as a picture like PNG or JPEG, or you could export as PDF. So I think picture will be better. So you could copy the picture and attach it to your report, or include it in your assignment. So either one of them should work. Just don't save it. Don't send it to me if it's an assignment as the format for diagram. So let's just see how that happens. If you go to export as, let's pick PNG. Can keep this as the default, then just export, and then you click here your device, because these are the different options. You could send it to Dropbox, to Google Drive, OneDrive, but let's just pick the device, and then you save it. Just remember which site you are using, and make sure to give it a name, and make sure to remember where you saved it. So that hopefully can help you learn how to do the diagrams, because you are going to do a homework for doing a flowcharts and Pseudocode for this to make sure you learned how to do these activities. Okay, thank you.